it's good to calculate what is our stress max and what is our stress mean, okay? If the normal procedure, okay? So you have to not only check the shear. So for this case, what is going on is the shear is the control, right? But we also have to check that the yield, right? So this is minus, this is plus. The circle is in the box, okay? So if I'm going to sketch the box, okay, so I'm going to do a realistic sketch, okay? So if I'm going to sketch the box, this is the box. No wonder. Okay, it's okay. 2, 4, 6, 8, 10. Okay, 2, 4, 6. Okay, it's just a sketch. Okay, I want to ensure that the box, okay, is inside this frame. Okay, right. So this is our stress yield line. This is your minus stress yield line. Okay, so from here, it's so straightforward that we just calculate stress X or stress max will be equal to stress X, which is equal to what is our stress X? 211.62 times 10 to the power 6 divided by 2. And then this will be equal to, now you don't need to put the other value in. You don't need to put this value in because you know that this value over here, right, which correspond to this value equal over here, which is equal to 125. Okay, so plus by 125 times 10 to the power 6, right? So the normal stress over here, before I go on, the normal stress is in tensile, right? Yeah, okay. So 211.62 power 6 divided by 2 plus by 125 power 6. So it's 211.62 power 6 divided by 2 plus by 125 power 6. So it's equal to 230.81 times 10 to the power 6 Pascal. And the stress mean will be equal to 211.62 times 10 to the power 6 divided by 2 minus by 125 times 10 to the power 6. Okay, so 211.62 power 6 divided by 2 minus 125 power 6 is equal to minus 19.19 times 10 to the power 6 Pascal. So this is less than 250 megapascal. This is greater than minus 250 megapascal. Okay, so the structure will not yield. Okay, there's no point checking the shear because if we check the shear, we know that the shear, right? We know that the shear max and the shear calculated is equal to what? Right? Because this is the value that we use. Okay. So this is for question number 6. Okay. Again, just a reminder. Okay. If you cannot remember the formula, if you cannot, so there are two cases. One is when stress max or stress mean is equal to 0, one is not. Okay. So this is a important formula. Okay. If you, sorry. If you want to memorize, it's up to you. Okay. If you don't memorize like what you see me do, okay, just draw the circle and you derive out. Okay. But in the exam, you have to draw 3D mole circle to show me that stress mean is not equal to 0. Okay. So only after you show me when stress mean is not equal to 0, then you can use this formula or not. I don't know why you use this formula and not the other. Okay. Okay. Another question or something that anyone want to clarify? Yeah, I just draw the circle to show me stress mean is not equal to 0 or stress max is not equal to 0. So ND asks, do we have to show the equation derivation and show that the circle for full marks? No. Okay, you just show me, you just need to sketch 3D mole circle and show me that stress max and stress mean are not equal to 0. That's why you apply that formula. Okay. Anything else to clarify? Any homework question that is still confusing you? Homework 7. Oh, this one. Homework 7, question number 2. Right, so we know that V is equal to 2 times 10 to the power 3 Newton. And we know that S is equal to 75 millimeters or 0.075 meters. And we are given that each nail has a diameter. The diameter of the nail is equal to 4 times 10 to the power minus 3 meters. So we are asked to find the average stress for each nail. So I'm not going to find the second moment of area. I'm just going to take from, you all should be really good at this already. 63.5417 times 10 to the power minus 6. And the Y bar, by looking at this, the Y bar is equal to 0.1375 meter. And I believe this is from bottom. If I'm going to find out from the top, it's equal to 0.2 minus 0.1375 is equal to 0.0625 meter from top. Okay, so one is from the bottom, one is from the top. So how about we do this? We know Q is equal, before we go on, the average stress of the nail, right, is equal to force divided by area, right? So from this force divided by area, Okay. Right. So it's controlled. Y'all can hear me now, right? It's controlled by the major web. The Q is controlled by major web. So you see Q will go one side, Q will go on the other side. Rule number one is what? The shear flow will distribute throughout the entire member, right? So in that context, this is the first moment of area you have to take. Then you have 2Q, right? And then we realize that you have failure, well, you're going to consider failure on one side and also failure on the other side. Okay, to look at the complete Q. So now we're going to look at Q. So if we were to have our transformation, right? So this is our X, right? So the the first moment, so no, this is Z. Okay. So we're going to find the first moment of area about the Z-axis. So the width is 0.2. The depth is 0.05. The Y bar is 0.0625 minus by 0.05 divided by 2. Okay. So this in terms will be equal to 0.0625 minus 0.05 divided by 2. Times by 0.05 times by 0.2. So the first moment of area is 375 times 10 to the power minus 6 meter cube. Okay. Right. So now the F you have to consider because you have one side and the other side, right? So now this is equal to 2F divided by the spacing, which is equal to 0.075. And then your V given, which is 2 times 10 to the power minus 2 times 10 to the power 3. Is it 2 times 10? Yeah, it's 2 times 10 to the power 3. Multiply by Q, 375 times 10 to the power minus 6. Divide by the, you realize that the formula is really easy. Can you see that? Right? The formula is really straightforward. The problem is this, okay? In order to do this, right, you have to analyze. And in order to analyze, you need to do this. Okay, you have to follow the rules that are specified. So that's why 3A failure rate is very high, because we are not teaching you procedure. Okay, we are teaching you analysis. You get what I mean? Okay, so you have to analyze in order to do. I think I don't need to say this anymore because you have done the two-term test already. It's the analysis. Okay, so from here, the shear stress of the nail is equal to 442.623 divided by pi, and the radius is 0.002123. Yep, squared. Okay, so this is equal to 442.623 divided by pi divided by 0.002 squared is equal to 35.222223 times 10 to the power 6. Okay, so that is the shear stress of the nail. Now, the shear stress of the nail, if we were to look at the nail, okay, why we can just divide by area, right? We are calculating this stress over here, right? So when we are calculating this stress, if I pick an element, right? If I were to draw an element down here, right? The shear stress is in this direction, the shear stress acting in the other direction. These two shear stress magnitude are the same. So this is the cross-sectional area. So that's why we take this cross-sectional area. That's why we just do force divide by area. Okay, that's straightforward. Are we clear? Okay, Any other question before I let you go? Anyone? Okay, so from now on, if you have any questions, okay, go on to Teams and write Eugene a question with this. Can we meet? Okay, then we arrange a time to meet online. Okay, if not, I'll see you guys on Thursday. Okay. As I said, any question you can just ask. Okay, if that's the case, that's the end of the lecture. Thank you for your time and revise well. Okay, that's all. Bye. Or I'll still stay behind. Okay.